Now we're going to look at a new type of cipher called a polyalphabetic cipher. In particular, we're going to look at the Vigenere cipher. So first we're going to explain how polyalphabetic ciphers work. Then we're going to define the Vigenere cipher. And then finally we're going to do a sample encryption and decryption for the Vigenere cipher. Alright, so first of all we're going to remember the old days, which actually weren't so long ago, but they're going to seem that way in a little bit. Monoalphabetic ciphers. What happened with those is two things. First of all, each plain text letter is replaced with another letter to create the ciphertext letter. But it's always represented by the same ciphertext letter. For instance, if A is represented by ciphertext F in one place, in another place in the message, A will again be represented by F. Polyalphabetic ciphers take this requirement away. So it's still going to be the case that each plain text letter is represented by another letter in ciphertext, except that that letter will depend also on the location of the letter within the message. So not only does it matter what message you are encrypting, or what letter you are encrypting, it matters where that letter lies in the message. So for example, if B is like the first character in your cipher, it could possibly be that it may be encrypted by F when it's the first character, but if it's the 10th character, it may be encrypted by X, something else. Okay? So what happens is with your key, each letter has a list, potentially a list of possible ciphertext letters, one for each possible place it can appear in the message. That could make for a very complicated key. Our idea is to try to take this idea, apply this idea, but try to make things more manageable. So here's what we do for the Vigenere cipher. We want an elegant way to figure out which ciphertext goes with which letter that you're encrypting and each position that letter could be in. And what we're actually going to be able to do is do that with a keyword. So it's a very simple key that can do a very complicated cipher. The keyword is going to tell you which position goes with which plain text ciphertext pair. So I'm going to demonstrate this on an example. So our keyword is going to be Rosanna, and the plain text that we are going to encrypt is I bless the rains. Now, each letter of the key is going to tell us how to line up the alphabet in regular order with the ciphertext. So we're going to have actually a bunch of keys for encrypting our letters, but what key we use is going to depend on what letter we have in that keyword. So for instance, the first letter in the keyword is R, and that is going to tell us which key to use. So we're going to line up our letters like we did before, A through Z. I can only fit A through M on this first line, but underneath that we are going to list the letters in alphabetical order, but not starting with A, but starting with R, which is the first keyword of first letter of our keyword. So instead of having A, B, C, D, E, F, and G, we're going to have R, S, T, U, V, W, X, Y, Z, and we're going to continue, right? Once we get to Z, we're going to cycle back to A, and then we're going to continue all along the alphabet. And what this does is it generates a key for that first letter. So our first letter of our message is I, and so where are we going to do? We're going to find the I in that first row. And right below it is the letter Z, so the letter I is going to be encrypted as Z. And then we're going to continue along the message, but we're also going to continue along the key. So for instance, for the second letter, we're going to look at the second letter of the key and the second letter of the plain text. That second letter of the key is going to tell us what our monoalphabetic key is going to be for that second letter. So for instance, we are going to have A through Z on top. On the bottom, we are going to have all the letters in alphabetical order, but this time we're going to start with the letter O. And then since we're encrypting the letter B, we look for the letter B on the top, and right below that is a P. So we encrypt our second letter as the letter P. And we continue this for all the other letters as well. For the third letters, it's going to be S for the key and L for the plain text. So the S tells us what the key is going to be like. We're going to start the bottom row with S and go in alphabetical order, cycling around to A once we get to Z. And then we're going to look for L, and right below that is the letter D, so we're going to encrypt the letter L as D. And then we keep on going, right? we have the fourth letter is A in the key and E in the plain text. That A is going to, actually the A is going to be interesting. It's going to determine the key. Not a very exciting key if we were doing a monoalphabetic cipher, but since nobody knows exactly what letter goes with what, it could still be considered a tricky cipher, right? It's going to be easy to encrypt though. The E, we look right below it, it is, well, E, because everything gets lined up, and so our fourth letter in the ciphertext is E. And so we keep on going. The next one is N and S. We start with N in our alphabet to make our key, and we look for S in the top row, and right below that is F. And we keep on going. The next the next N gives us our next key. We look below S, we get F again. We look below, we make the letter, use the letter A in the key to make our key, and then we look below T, and that gives us a T. And now we're at the end of our keyword, and that could be a little bit disturbing because we're not out of letters for our plain text. So the question you might ask is, what do we do? Well, guess what? We're going to go right back to the letter R to start over again. We're going to continue along the plain text to the letter H, but we're going to use R as our next letter to determine our key for our alphabet. So we're going to start with R and so on. Look for H in that top row. Right below that is a Y. And then keep on going all the way until you get to the end of the message. And then that generates your ciphertext. All right, that takes us to the end of that message. Now let's see how decryption works. Decryption is actually going to work the exact same way, except when we look for letters to decrypt, we're going to look on the second row for the letter instead of on the top row. Everything else is going to be the same. So we're still going to look at the first letter of the key and the ciphertext. The first letter of the key is still going to generate the key for that first letter. But now we're going to look at the bottom. If you see where that K is over on the top pair of rows, it's going to be right below the letter I. That means the letter K gets encrypted as, or decrypted, excuse me, as I. We go to the second letter, that's B, the letter for the ciphertext, O for the key. That O is going to determine our key for that second letter. We look for B in the second row. Right above it is an N, hooray. And so that letter B gets decrypted as N. Our third letter, that letter L in the key is going to tell us what our key is for that particular letter. We look for D in the bottom row. It's right below the S, and we keep on going. Right. The next one is D. That's right. For our ciphertext. O is for our key. That means the O is going to determine what our key is for that letter. We're going to look for D in the second row. Right above it is a P, and keep on going. Right. Keep on going. The C gets encrypted as an I. That I gets encrypted as an R. That C gets encrypted as an A. The H gets encrypted as a T. The T gets encrypted as an I. Let me see. The C on the bottom gets encrypted as an O right above it, and then finally the H on the bottom gets encrypted as an N right above it, and we get inspiration. Now, one note I want to make about this, you notice that for every single letter, I had to generate an entirely new key. That can be really, really tedious, especially since a lot of them get repeated anyway. What I have included a chart with this video. If you look in the if you look with the in-class activities, there's a little chart that has all the possible ways you can write the alphabet in cyclical alphabetical order, with the normal one A through Z on the top. And so what you can do there is it makes it a lot easier to encrypt and decrypt, because all you have to do is look for, if let's say your letter's an L, you go down to the row that starts with an L, and that gives you your alphabet right away that you can use as your key for that particular letter. Anyway, you should check it out. It should make things a little bit easier. It's not the greatest to look at, but it's the best that I could do given the resources that I had. Anyway, now you're ready to look for the activities for the Vigenere Cipher on the PDF file included with this video.